Text Analysis, Python, Models, and Lexicons. Written by David Feldspar. Narrated by Jason R. Gray. Python for Text Analysis. This is a practical course in Python, geared towards those who want to get some hands-on experience working with language data. No knowledge of programming is required or presupposed. We will work with Python 3. If you haven't worked with Python before, this course is meant to introduce you to the basics of Python programming language. There is a lot to discover about Python and programming in general, and you will probably learn something new every day if you continue programming after this course. Our goal for you is to become an independent programmer who is able to find solutions to new problems. You will learn how to work with the standard library of Python, learn how to deal with different file types, for example, plain text, CSV, TSV, JSON or JSON, and XML. Learn how to use some external libraries to analyze texts. Learn how to document and share your code and results. We will focus on readability and understandability so that you will be able to share your code and results with others, and reuse your code in the future. This is a practical course in which you will get a lot of hands-on experience. Due to the nature of this course, active participation is required. Core Principles. Good software is approachable. It can be understood completely in independent, easy pieces. You don't need to understand everything before you can understand anything. Good software is consistent. It lets you take what you've learned about one part and extrapolate it to the rest. It doesn't self-contradict. It is parsimonious, avoiding superfluous elements. Good software explains itself. It has affordances for learning and discovery. It is role-expressive and minimizes hidden magic. The good software teaches. It doesn't just automate an existing task, but provides insight or imparts knowledge, such as a best practice or a new perspective on a problem. Good software is for humans. It is cognizant of people and the reality in which they live. It does not expect elaborate and arbitrary rules to be memorized. It anticipates the need for learning and debugging. The 15-minute rule. When you are just learning how to program, it sometimes happens that you get stuck and you don't know what to do next. This is normal. There are many fantastic resources online that we encourage you to use to solve your problem on your own. But we don't want this to be a frustrating experience for you. So, if you're stuck for more than 15 minutes, please contact us. No matter how small the problem, if you're stuck, you're stuck. Your first text mining project with Python in 3 steps. Every day, we generate huge amounts of text online, creating vast quantities of data about what is happening in the world and what people think. All of this text data is an invaluable resource that can be mined in order to generate meaningful business insights for analysts and organizations. However, analyzing all this content isn't easy, since converting text produced by people into structured information to analyze with a machine is a complex task. In recent years, though, natural language processing and text mining has become a lot more accessible for data scientists, analysts, and developers alike. There is a massive amount of resources, code libraries, services, and APIs out there which can all help you embark on your first NLP project. For this how-to post, we thought we'd put together a 3-step and end-to-end guide to your first introductory NLP project. We'll start from scratch by showing you how to build a corpus of language data and how to analyze this text, and then we'll finish by visualizing the results. We've split this post into 3 steps. Each of these steps will do 2 things: show a core task that will get you familiar with NLP basics, and also introduce you to some common APIs and code libraries for each of the tasks. The tasks we've selected are: first, build a corpus using Tweepy to gather sample text data from Twitter's API. Second, analyzing text, analyzing the sentiment of a piece of text with our own SDK. And third, visualizing results, how to use pandas and matplotlib to see the results of your work. Step 1. Build a corpus. You can build a corpus from anywhere. Maybe you have a large collection of emails you want to analyze, a collection of customer feedback in NPS surveys that you want to dive into, or maybe you want to focus on the voice of your customers online. There are lots of options open to you, but for the purpose of this post, we're going to use Twitter as our focus for building a corpus. Twitter is a very useful source of contextual content. It's easily accessible, it's public, and it offers an insight into a huge volume of text that contains public opinion. Accessing the Twitter Search API using Python is pretty easy. There are lots of libraries available, but our favorite option is Tweepy. In this step, we're going to use Tweepy to ask the Twitter API for 500 of the most recent tweets that contain our search term. And then we'll write the tweets to a text file, with each tweet on its own line. This will make it easy for us to analyze each tweet separately in the next step. You can install Tweepy using pip. Once completed, open a Python shell to double-check that it's been installed correctly. First, we need to get permission from Twitter to gather tweets from the Search API, so you need to sign up as a developer to get your consumer keys and access tokens, which should take you 3 or 4 minutes. Next, you need to build your search query by adding your search term to the Q equals field. You will also need to add some further parameters like the language, the number of results you want to be returned, and the time period to search in. You can get very specific about what you want to search for on Twitter. To make a more complicated query, take a look at the list of operators you can use the API to search within the Search API introduction. Step 2. Analyze sentiment. So once we've collected the text of the tweets that we want to analyze, we can use more advanced NLP tools to start extracting information from it. Sentiment analysis is a great example of this, since it tells us whether people were expressing the positive, negative, or neutral sentiment in the text we have. For sentiment analysis, we're going to use our own AYLIEN or Alien text API. Just like within the Twitter Search API, you'll need to sign up for the free plan to grab your API key. Don't worry. Free means free permanently. There's no credit card required, and we don't harass you with promotional stuff. This plan gives you 1,000 calls to the API per month, free of charge. Again, you can install using pip. Then, make sure the SDK has installed correctly from your Python shell. Once you've got your app key and your application ID, insert them into the code below to get started with your first call to the API from the Python shell. We also have extensive documentation in 7 popular languages. Our API lets you make your first call to the API with just 4 lines of code. This will return JSON results to you with metadata, just like our results from the Twitter API. So now, we need to analyze our corpus from step 1. To do this, we need to analyze every tweet separately. The script below uses the IO module to open a new .csv file and write the column headers tweet and sentiment. And then it opens and reads the .txt file containing our tweets. Then, for each tweet in the .txt file, it sends the tweet to the Alien API, extracts the sentiment prediction from the JSON that the Alien API returns, and writes this to the .csv file next to the tweet itself. This will give us a .csv file with 2 columns, the text of a tweet and the sentiment of the tweet, as predicted by the Alien API. We can look through this file to verify the results, and also visualize our results to see some metrics on how people felt about whatever our search query was. You might notice on the final line of the script that when the script goes to write the tweet text to the file, we're actually writing the tweet as it was returned by the alien API rather than the tweet from the .txt file. They are both identical pieces of text, but we've chosen to write the text from the API just to make sure we're reading the exact text that the API analyzed. This is just to make it clearer if we've made an error somehow. Step 3. Visualize your results. So far, we've used an API to gather text from Twitter and used our text analysis API to analyze whether people were speaking positively or negatively in their tweet. At this point, you have a couple options with what you do with the results. You can feed this structured information about sentiment into whatever solution you're building, which could be anything from a simple social listening app or even an automated report on the public reaction to a campaign. You could also use the data to build informative visualizations, which is what we'll do in this final step. For this step, we're going to use matplotlib to visualize our data and pandas to read the .csv file, two Python libraries that are easy to get up and running. You'll be able to create a visualization from the command line or save it as a .png file. Install both using pip. Pip install matplotlib. Pip install pandas. The script below opens up our .csv file and then uses pandas to read the column titled sentiment. It uses counter to count how many times each sentiment appears, and then matplotlib plots counter's results to a color-coded pie chart. You'll need to enter your search query to the yourText variable for presentation reasons. If you want to save your chart to a .png file instead of just showing it, replace plot.show on the last line with savefig, open parentheses, yourchartname.png, close parentheses. Sentiment analysis, where AI meets psychology. In recent times, research activities in the area of opinion, sentiment, emotion, and/or mood in natural language texts, speech, music, and other media have become the mainstream research under the umbrella of subjectivity analysis and affective computing. These tasks are considered vital since a decade from various academic and commercial perspectives. The popularity of the Internet and the rapid expansion of social media, a variety of user-generated contents have become available online. However, the major challenges are how to process the user-generated contents, such as texts, audio, and images, and how to organize them in some meaningful ways. The common interest areas where artificial intelligence, or AI, meets sentiment analysis can be viewed from 4 aspects of the problem, and the aspects can be grouped as object identification, feature extraction, orientation classification, and integration. The existing reported solutions or available systems are still far from being perfect, or fail to meet the satisfaction level of the end users. The main issue may be that there are many conceptual rules that govern sentiment, and there are even more clues, possibly unlimited, that can convey these concepts from realization to verbalization of a human being. Human psychology may provide the unrealized clues and govern the sentiment realization. The important issues that need attention include how various psychological phenomena can be explained in computational terms, and which AI concepts and computer methodologies will be proved as the most useful ingredients from the psychologist's point of view. Sentiment analysis from natural language texts is a multifaceted and multidisciplinary problem. Research efforts are being carried out for identification of positive or negative polarity of the evaluative text, and also for the development of devices that recognize human affect, display and model emotions from textual contents. Identifying strength of sentiment in figurative texts, or aspects and categories from the reviews, detecting stance from the tweet data, identifying the psychological condition of persons from chat, even detecting sentiment in clinical texts, and the moods from music, are the recent trends in the field of sentiment analysis. Mood analysis from music is an emerging area in music information retrieval, or MIR. The popularity of downloading and purchasing music from online music shops has increased. Similarly, with the rapid evolvement of technology, music is just a few clicks away on almost any personal gadget, be it computers, portable music players, or smartphones. This fact underlines the importance of developing an automated process for its organization, management, search, as well as the generation of playlists and various other music-related applications. Recently, MIR, based on emotions or mood, has attracted researchers from all over the world because of its highly motivated implications in human-computer interactions. In addition to question answering or information retrieval systems, the topic sentiment analysis is being applied as a new research method for mass opinion estimation, for reliability, validity, and sample bias, psychiatric treatments, corporate reputation management, political orientation categorization, stock market prediction, customer preference, or public opinion study, and so on. Techniques from artificial intelligence play the important roles in these tasks. What are the first-person, second-person, and third-person points of views? Which is used for formal essays? The first-person point of view is mainly used in fiction, when a story is told from the point of view of one of the characters, using I and me throughout the story. This point of view allows the reader to see all of the action of the story through the eyes of that single character. When the I of the story is the main character, the reader can, quite literally, get in the head of the narrator, experiencing all of the main character's thoughts and feelings. You would rarely use this point of view in a formal essay, because when writing an essay, you usually want to remain objective in the argument you're presenting. The second-person point of view isn't used very much, simply because it's very difficult to write from this point of view without confusing the readers, who might think the author is addressing them. This point of view is also used mainly in fiction, when the story's narrator uses you to address the main character, such as in a story where the author or narrator is addressing a younger version of himself. Such a point of view would also be inappropriate for a formal essay. The third-person point of view is the one you want to use for a formal essay. In this point of view, the author uses he and she to describe the action of the story. This point of view allows for distance between the author and the characters, as well as for an all-seeing, all-knowing, or omniscient narrator. Using this point of view in a formal essay enables you to be objective in the argument you're presenting and not bring your personal feelings, thoughts, or experiences into the essay. First versus the third person. Pronouns are a set of words that replace nouns. They can be used to make your work less complicated and less repetitive. Examples of pronouns include first person, I, we, me, us. Second person, you. Third person, he, she, it, they, him, her, them. For some assignments, it is appropriate to use the first person. However, for other assignments, the third person is preferred. Sometimes a mixture of the first and third person should be used for different purposes. So, check your assignment guidelines for each assignment, as it will differ for the different assignment types, different style guides, and different disciplines. If you are unsure, then check with your course coordinator. First-person preference. The first person can be used to make writing more concise when providing personal reflection, stating a position, or outlining the structure of an assignment. Some disciplines and lecturers allow or encourage the use of the first or second person, I, we, you, etc. The use of the first person is also recommended or allowed in some style guides. For example, In the American Psychological Association Publication Manual, 6th edition, it is recommended that the authors use first person to avoid ambiguity and anthropomorphism. How to use the first person. The following examples illustrate some of the ways you can use the first person in your writing. Example 1. Structuring an essay. Example 2. Describing research you conducted. Example 3. Describing research you conducted. Avoiding subjectivity using the first person. Academic training requires students to support the claims they make by providing solid arguments and/or evidence. So, even when the first person is used in academic writing, it can, and usually should, still sound objective. How to sound objective using the first person when making a claim or stating an argument. The following examples illustrate ways to use the first person in your writing while sounding objective. In other words, making it clear that you are not just expressing an unsupported personal view, and that you are concerned about facts and/or reasons, rather than being influenced by personal feelings or biases. How to use the first person in reflective writing. Reflective writing relies on personal experience, so it is necessary to use the first person. Third-person preference. Some disciplines or lecturers discourage the use of the first or second person, I, we, you, etc., and prefer the use of the third person because it makes writing sound objective. How to avoid the first person. The following examples illustrate ways to write without using the first person. Example 1. Structuring the essay. Example 2. Making a claim or stating an argument. Example 3. Describing research you conducted. Sentiment lexicons. A sentiment lexicon is merely composed of sentiment words and sentiment phrases, or idioms, characterized by sentiment polarity, positive or negative, and by sentimental strength. For example, the word excellent has positive polarity and high strength, whereas the word good is also positive but has a lower strength. Once a lexicon is built and in place, a range of different approaches can be used to classify the sentiment in a text as positive or negative. These approaches range from simply computing the difference between the sum of the scores for the positive lexicon and the sum of the scores for the negative lexicon, and subsequently classifying the sentiment in the text according to the sign of the difference. Supervised learning. Given a set of documents with known sentiment class, the material can be used to train a model to classify the sentiment class of new documents. A major challenge in sentiment classification is that the classification method normally is highly sensitive to the domain. A method that performs well in one domain may not perform well in a different domain. It is worth mentioning that the latter problem is common and well studied in the field of machine learning, since supervised learning is especially sensitive to the domain, and typically it performs well only in the domain of annotated documents. The latter problem is referred to in the literature as cross-domain classification. Several methods have been suggested to overcome this challenge in the field of sentiment analysis. However, they are merely inspired by the legacy research on cross-domain classification in the field of machine learning. These methods are often referred to as cross-domain sentiment classification. The premises of these methods is to adjust a supervised classifier to the domain of interest. The approaches consist of either using a small annotated corpus or, alternatively, a large non-annotated corpus from the domain of interest. In this paper, we study another problem, which is very common in practice, but, to the best of our knowledge, has not been studied in the literature. For many languages, several different sentiment lexicons are available, and it is often difficult to know which sentiment lexicon is preferable. Ideally, one would like to use the information from all the lexicons, but this is often challenging since the scores of a sentiment word vary between the lexicons and may also be contradictory. In addition, there is usually also a large amount of text from the domain of interest. a large set of product reviews that we want to classify with respect to sentiment. We present a method that builds domain-specific sentiment lexicons using information from the sentiment lexicons and the corpus from the domain of interest in an advantageous way. The suggested method is based on Bayesian decision theory. Before we proceed to present our solution and our experimental results, we shall present a brief review of the related work. Most of the research within cross-domain sentiment classification focuses on devising approaches to join in formation from labeled and/or unlabeled corpuses from different domains and the domain of interest to improve sentiment classification. Context: the task of automatically detecting whether a piece of text is positive or negative generally relies on a hand-curated list of words with the positive sentiment, good, great, awesome, and the negative sentiment, bad, gross, awful. This dataset contains both positive and negative sentiment for 81 languages. Content: the sentiment lexicons in this dataset were generated via graph propagation based on a knowledge graph, a graphical representation of real-world entities and the links between them. The general intuition is that words which are closely linked on a knowledge graph probably have similar sentiment polarities. For this project, sentiments were generated based on English sentiment lexicons. This dataset contains sentiment lexicons for the following languages: Afrikaans, Albanian, Arabic, Aragonese, Armenian, Azerbaijani, Basque, Belarusian, Bengali, Bosnian, Breton, Bulgarian, Catalan, Chinese, Croatian, Czech, Danish, Dutch, Esperanto, Estonian, Faroese, Finnish, French, Galician, Georgian, German, Greek, Guarati, Haitian Creole, Hebrew, Hindi, Hungarian, Icelandic, Idu, Indonesian, Interlingua, Irish, Italian, Kannada, Khmer, Kyrgyz, Korean, Kurdish, Latin, Latvian, Lithuanian, Luxembourgish, Macedonian, Malay, Maltese, Marathi, Norwegian, Persian, Polish, Portuguese, Romanian, Romanish, Russian, Scottish, Serbian, Slovak, Slovene, Spanish, Swahili, Swedish, Tagalog, Tamil, Telugu, Thai, Turkish, Turkmen, Ukrainian, Urdu, Vietnamese, Volapük, Walloon, Welsh, Western Frisian, Yiddish. Lexicon-based sentiment analysis, comparative evaluation of 6 sentiment lexicons. This chapter introduces a new general-purpose sentiment lexicon called WKWSCI Sentiment Lexicon and compares it to 5 existing lexicons: Hu and Liu Opinion Lexicon, Multi-Perspective Question Answering, or MPQA, Subjectivity Lexicon, General Inquirer, National Research Council Canada, or NRC Word Sentiment Association Lexicon, and Semantic Orientation Calculator, or SOCAL lexicon. The effectiveness of the sentiment lexicons for sentiment categorization at the document level and sentence level was evaluated using an Amazon Review dataset and News Headline dataset. WKWSCI, MPQA, Hu and Liu, and SOCAL lexicons are equally good for product review sentiment categorization, obtaining accuracy rates of 75% to 77% when appropriate weights are used for different categories of sentiment words. However, when a training corpus is not available, Hu and Liu obtain the best accuracy with a simple-minded approach of counting positive and negative words for both document-level and sentence-level sentiment categorization. The WKWSCI lexicon obtained the best accuracy of 69% on the news headline sentiment categorization task. and the sentiment strength values obtained a Pearson correlation of 0.57 with human-assigned sentiment values. It is recommended that the Hu and Liu lexicon be used for product review texts, and the WKWSCI lexicon for non-review texts. Subjectivity. Subjectivity refers to how someone's judgment is shaped by personal opinions and feelings instead of outside influences. Subjectivity is partially responsible for why one person loves an abstract painting while another person hates it. Since a subject is a person, subjectivity refers to how a person's own uniqueness influences their perceptions. For example, if you have 6 sisters, that might influence how you view women or families. It's part of your subjectivity. Subjectivity is a form of bias and also individuality. Subjectivity is the opposite of objectivity, which is based purely on the facts and isn't personal. We expect judges to put aside their subjectivity and make decisions based on objectivity. The surprising benefits of sarcasm. Sarcasm is the lowest form of wit, but the highest form of intelligence, wrote that connoisseur of wit, Oscar Wilde. Whether sarcasm is a sign of intelligence or not, communication experts and marriage counselors alike typically advise us to stay away from this particular form of expression. The reason is simple. Sarcasm expresses the poisonous sting of contempt, hurting others and harming relationships. As a form of communication, sarcasm takes on the debt of conflict. Sarcasm involves constructing or exposing contradictions between intended meanings. The most common form of verbal irony, sarcasm is often used to humorously convey thinly veiled disapproval or scorn. "Pat, don't work so hard," a boss might say upon catching his assistant surfing the internet. Early research on sarcasm explored how people interpret statements and found that, as expected, sarcasm makes a sentiment sound more critical. In one laboratory study, participants read scenarios in which, for instance, one person did something that could be viewed negatively, such as smoking, and a second person commented on the behavior to the first person, either literally, as in, "I see you don't have a healthy concern for your lungs," or sarcastically, as in, "I see you have a healthy concern for your lungs." Sarcasm involves constructing or exposing contradictions between intended meanings. Other research has shown that sarcasm can be easily misinterpreted, particularly when communicated electronically. In one study, 30 pairs of university students were given a list of statements to communicate, half of which were sarcastic and half of which were serious. Some students communicated their messages via email, and others via voice recordings. Participants who received the voice messages accurately gleaned the sarcasm, or lack thereof, 73% of the time. But those who received the statements via email did so only 56% of the time, hardly better than chance. By comparison, the emailers had anticipated that 78% of their participants would pick up on the sarcasm inherent in their sarcastic statements. That is, they badly overestimated their ability to communicate the tenor of their sarcastic statements via email. What's more, the recipients of the sarcastic emails were also decidedly overconfident. They guessed they would correctly interpret the tone of the emails they received about 90% of the time. They were considerably less overconfident about their ability to interpret voice messages. Sarcasm can be interpreted negatively and thus cause relationship costs. So, how do we harness its creative benefits without creating the type of conflict that can damage a relationship? It comes down to trust. Our studies show that, given the same content and tone, sarcasm expressed toward or received from someone we trust is less conflict-provoking than sarcasm expressed toward or received from someone we distrust. Of course, if we were to vary the tone and content, it would make a difference too. Given an extremely harsh tone and critical content, even trust might not be enough. Examples of sarcasm. Sarcasm is an ironic or satirical remark that seems to be praising someone or something, but is really taunting or cutting. Sarcasm can be used to hurt or offend, or can be used for comic effect. Practical sarcasm examples. I'm trying to imagine you with a personality. I work 40 hours a week to be this poor. Is it time for your medication or mine? Well, this day was a total waste of makeup. Whatever kind of look you were going for, you missed. Not the brightest crayon in the box now, are we? Nice perfume. Must you marinate in it? Earth is full. Go home. Suburbia, where they tear out the trees and then name streets after them. This isn't an office, it's hell with fluorescent lighting. I majored in liberal arts. Will that be for here or to go? Don't bother me. I'm living happily ever after. Conditional sentences. What are conditional sentences? With examples. Conditional sentences, also known as conditional clauses or if clauses, are made up of two halves. One half, the half with the word if in it, is a condition, and the other half, the main clause, states the action to occur if the condition is fulfilled. The types of conditional sentence. There are three types of conditional sentence. Conditional sentence type 1. Type 1 sentences are used when it is likely that the condition will be fulfilled. It is formed like this: if plus simple present, will plus verb. Examples of conditional sentence type 1. If you swallow some of the cleaning fluid, it will kill you. If I get a little humility, I will be perfect. Conditional sentence type 2. Type 2 sentences are used when it is unlikely that the condition will be fulfilled. It is formed like this: if plus simple past, comma, would plus verb. Examples of conditional sentence type 2. If you swallowed some of the cleaning fluid, it would kill you. If I had a little humility, I would be perfect. Conditional sentence type 3. Type 3 sentences are used when it is impossible for the condition to be fulfilled because the possibility has already passed. It is formed like this: if plus past perfect, comma, would have plus past participle. Examples of conditional sentence type 3. If you had swallowed some of the cleaning fluid, it would have killed you. If I had a little humility, I would have been perfect. Using commas in conditional sentences. When the condition is at the start of the sentence, like in all of the examples above, it is usual to separate it from the main clause with a comma. However, if the condition is at the back of the sentence, it is less common to use a comma. You can still use a comma to assist your reader if you think it aids understanding. It will kill you if you swallow some of that cleaning fluid. I would have been perfect if I had had a little humility. What are the different types of conditional sentences? There are 4 different types of conditional sentences in English. Each expresses a different degree of probability that a situation will occur or would have occurred under certain circumstances. 0 conditional sentences, first conditional sentences, second conditional sentences, third conditional sentences. Let's look at each of these different types of conditional sentences in more detail. How to use 0 conditional sentences. 0 conditional sentences express general truths, situations in which one thing always causes another. When you use a 0 conditional, you're talking about a general truth, rather than a specific instance of something. Consider the following examples. If you don't brush your teeth, you get cavities. When people smoke cigarettes, their health suffers. There are a couple of things to take note of in the above sentences in which the 0 conditional is used. First, when using the zero conditional, the correct tense to use in both clauses is the simple present tense. A common mistake is to use the simple future tense, as in, when people smoke cigarettes, their health will suffer. Secondly, notice that the words if and when can be used interchangeably in these zero conditional sentences. This is because the outcome will always be the same, so it doesn't matter if or when it happens. How to use first conditional sentences. First conditional sentences are used to express situations in which the outcome is likely, but not guaranteed, to happen in the future. Look at the examples below. If you rest, you will feel better. If you set your mind to a goal, you will eventually achieve it. Note that we use the simple present tense in the if clause and the simple future tense in the main clause, that is, the clause that expresses the likely outcome. This is how we indicate that under a certain condition, as expressed in the if clause, a specific result will likely happen in the future. Examine some of the common mistakes people use using the first conditional structure. Incorrect. If you will rest, you will feel better. Correct. If you rest, you will feel better. Explanation. Use the simple present tense in the if clause. Incorrect. If you set your mind to a goal, you eventually achieve it. Correct. If you set your mind to a goal, you'll eventually achieve it. Explanation. Use the zero conditional, i.e., simple present plus simple present, only when a certain result is guaranteed. If the result is likely, use the first conditional, i.e., simple present plus simple future. How to use second conditional sentences. Second conditional sentences are useful for expressing outcomes that are completely unrealistic or will not likely happen in the future. Consider the examples below. If I inherited $1 billion, I would travel to the moon. If I owned a zoo, I might let people interact with the animals more. Notice the correct way to structure second conditional sentences is to use the simple past tense in the if clause, and an auxiliary modal verb, for example, could, should, would, might, in the main clause, the one that expresses the unrealistic or unlikely outcome. The following sentences illustrate a couple of the common mistakes people make when using the second conditional. If I inherit $1 billion, I would travel to the moon. If I inherited $1 billion, I would travel to the moon. Explanation. When applying the second conditional, use the simple past tense in the if clause. If I owned a zoo, I will let people interact with the animals more. If I owned a zoo, I might let people interact with the animals more. Explanation. Use a modal auxiliary verb in the main clause when using the second conditional mood to express the unlikelihood that the result will actually happen. How to use third conditional sentences. Third conditional sentences are used to explain that present circumstances would be different if something different had happened in the past. Look at the following examples. If you had told me you needed a ride, I would have left earlier. If I had cleaned the house, I could have gone to the movies. These sentences express a condition that was likely enough, but did not actually happen in the past. The speaker in the first sentence was capable of leaving early, but did not. Along these same lines, the speaker in the second sentence was capable of cleaning the house, but did not. These are all conditions that were likely, but regrettably did not happen. Note that when using the third conditional, we use the past perfect, i.e., had plus past participle, in the if clause. The modal auxiliary, would, could, should, etc., plus have plus past participle in the main clause expresses the theoretical situation that could have happened. Consider these common mistakes when applying the third conditional. If you would have told me you needed a ride, I would have left earlier. If you had told me you needed a ride, I would have left earlier. Explanation. With third conditional sentences, do not use a modal auxiliary verb in the if clause. If I had cleaned the house, I could go to the movies. If I had cleaned the house, I could have gone to the movies. Explanation. The third conditional mood expresses a situation that could have only happened in the past if a certain condition had been met. That's why we use the modal auxiliary verb plus have plus the past participle. Exceptions and special cases when using conditional sentences. As with most topics in the English language, conditional sentences often present special cases in which unique rules must be applied. Use of the simple future in the if clause. Generally speaking, the simple future should only be used in the main clause. One exception is when the action in the if clause will take place after the action in the main clause. For example, consider the following sentence. If aspirin will ease my headache, I will take a couple tonight. The action in the if clause is the aspirin easing the headache, which will only take place after the speaker takes them later that night. Were to in the if clause. The verb phrase were to is sometimes used in conditional sentences when the likely or unlikely result is particularly awful or unthinkable. In this case, were to is used to place emphasis on this potential outcome. Consider these sentences. If I were to be sick, I would miss another day of work. If she were to be late again, she would have to have a conference with the manager. If the rent were to have been a penny more, they would not have been able to pay it. Note that the emphatic were to can be used to describe hypothetical scenarios in the present, future, and past. Punctuating conditional sentences. Despite the complex nature of conditional sentences, punctuating them properly is really simple. Here's the skinny. Use a comma after the if clause when the if clause precedes the main clause. If I'd had time, comma, I would have cleaned the house. If the main clause precedes the if clause, no punctuation is necessary. I would have cleaned the house if I'd had time. English conditionals explained. How to use the zero, first, second, and third conditionals. There are 4 kinds of a conditional sentence in English. First, the zero conditional. We make it with if plus present simple, comma, present simple. For example, if you sit in the sun for too long, you get burned. We use the zero conditional when we're talking about a result that will always happen. If the first part of the sentence is true, then the second will always follow. If you sit in the sun for too long, you'll always get burned. It's a natural consequence. Here are some more examples. If you heat water to 100%, it boils. If we eat too much, we put on weight. If I eat peanuts, I get sick. If you mix hydrogen and oxygen, you get water. Things to note. With the zero conditional, we are talking in general, not about one particular instance. We can usually replace the if with when without changing the meaning. We can change the order of the 2 parts. It's fine to say, you get water if you mix hydrogen and oxygen. The first conditional. We make it with if plus present simple, comma, will plus infinitive. For example, if it rains tomorrow, we'll go to the cinema. We use the first conditional to talk about things which might happen in the future. Of course, we can't know exactly what will happen in the future, but this describes possible things that might come true. Here are some more examples. If I have enough money, I'll buy a new dress. If the train is delayed, we'll be late. If she doesn't study, she'll fail the exam. If John keeps eating chocolate. Things to note. We can also change the order of the 2 parts in the first conditional. I'll buy a new dress if I have enough money. The second conditional. We make it with if plus past simple, comma, would plus infinitive. For example, if I had a lot of money, I would travel around the world. We use the second conditional in two situations. First, to talk about things in the future that probably won't happen. It could be that I'm imagining something I'd like that's very unlikely. For example, if I won the lottery, I would buy a big house. Another example, if I met George Clooney, I would marry him. Second, to talk about something in the present that is impossible because the first part of the sentence isn't true. For example, if I had her number, I would call her, but I don't have her number. Another example, if I had enough time, I would help you. Things to note. With the verb be, when we use I and he, she, it after the if and before the past simple, we often use were and not was. For example, if I were you, I wouldn't take that job. We can also swap the order in the second conditional. I would travel around the world if I had a lot of money. Fourth, the third conditional. We make it with if plus past perfect, comma, would have plus past participle. For example, if I had gone to bed early, I would have caught the train. We use the third conditional to talk about the past and to describe a situation that didn't happen, and to imagine the result of this situation. Here are some more examples. If she had studied, she would have passed the exam. But really, we know she didn't study, and so she didn't pass. If I hadn't studied English, I wouldn't have become a teacher. But I did study English. If we'd woken up earlier, we wouldn't have missed the plane. If they'd gone to bed at 10, they wouldn't be so tired today. Things to note. We can change the order with the third conditional too. I would have caught the train if I'd gone to bed early. Cross-language support. Definition. What does cross-language support mean? Cross-language support is the ability provided by the Common Language Runtime, or CLR, and the Common Language Specification, or CLS, of the .NET framework for interaction with code written in a different programming language. Cross-language support is a language interoperability feature with advantages, such as the reuse of types defined in other languages, a single environment for debugging and profiling due to the use of Microsoft Intermediate Language, or MSIL, and consistent exception handling, where exceptions are thrown in one language can be caught in another language. Thus, it acts as a tool for code reuse and efficient development processing. Implementation of cross-language support in .NET is somewhat similar to that of Java. In the case of .NET, the CLR converts the code generated in an intermediate language, similar to Java bytecode, to machine-specific code. Thus, the CLR forms a common platform for cross-language development, which includes cross-language inheritance, cross-language debugging, and cross-language exception handling. Technopedia explains cross-language support. The increase in the variety of tools and technologies necessitated the requirement for language interoperability. The design of .NET aims to address the issues faced while using Component Object Model, or COM components, where the type of client has to be considered before designing its interfaces. For scripting clients, the interface methods need to have automation-compatible parameters, which are not necessary for C++ clients. With the help of Common Type System, or CTS, value and reference types can be defined in any language and used from any other language. Additionally, the elimination of the DLL helped in problems faced in COM, and the introduction of side-by-side deployment of components in the .NET framework resolved the deployment issue faced while using multiple components. Managed code adhering to specifications of CLS is called CLS compliant. This helps the objects coded in different languages to communicate with each other. However, .NET does not restrict the components to only use features defined in the CTS, which cannot be used from other different languages. By setting the value of CLS compliant attribute for an assembly, the assembly can be CLS compliant and alert the compiler to issue warnings if there are any non-CLS compliant data types used in public and protected methods. CTS also plays a vital role in runtime support for cross-language integration by defining the set of rules for the language to follow and providing type safety, high-performance code execution, etc., along with a rich set of types used in a variety of languages. Negation words. Negation is a common strategy in argumentation. In arguing a point of view, it is often necessary to negate an opposing viewpoint, to refute an argument, and to remove misunderstanding through the use of negation. For example, by freedom, I do not mean the liberty to do whatever we like, but the exercising of a choice, for which we take full responsibility. Definition: studying abroad is not as rewarding as studying in a local university. Comparison and contrast. Smoking may provide temporary stimulation of the brain, but it is not the answer to chronic lack of sleep. Concession and rebuttal. Negatives and negation grammar rules. When you want to express the opposite meaning of a particular word or sentence, you can do it by inserting a negation. Negations are words like no, not, and never. If you wanted to express the opposite of I am here, for example, you could say, I am not here. Below, you'll find some common negative words used to negate ideas. Negative words: no, not, none, no one, nobody, nothing, neither, nowhere, never. Negative adverbs: hardly, scarcely, barely. Negative verbs: doesn't, isn't, wasn't, shouldn't, wouldn't, couldn't, won't, can't, don't. Modality. A modality is a way or mode in which something exists or is done. You might often see it used with reference to diagnostic modality, which is the way in which a disease or illness is diagnosed by a doctor. Modality shares its root with the word mode, meaning the way in which something happens or is experienced. A sensory modality is a way of sensing, like vision or hearing. Modality in someone's voice gives a sense of the person's mood. In logic, modality has to do with whether a proposition is necessary, possible, or impossible. In general, a modality is a particular way in which something exists. Markov model. The Markov model is an analytical framework that is frequently used in decision analysis and is probably the most common type of model used in economic evaluation of healthcare interventions. Markov models use disease states to represent all possible consequences of an intervention of interest. There are mutually exclusive and exhaustive, and so each individual represented in the model can be in one and only one of these disease states at any given time. Examples of health states that might be included in a simple Markov model for a cancer intervention are progression-free, post-progression, and dead. Individuals move, or transition, between disease states as their condition changes over time. Time itself is considered as discrete time periods called cycles, typically a certain number of weeks or months, and movements from one disease state to another, in subsequent time periods, are represented as transition probabilities. Time spent in each disease state for a single model cycle, and transitions between states, is associated with a cost and a health outcome. Costs and health outcomes are aggregated for a modeled cohort of patients over successive cycles to provide a summary of the cohort experience, which can be compared with the aggregate experience of a similar cohort. For example, one receiving a different or comparator intervention for the same condition. Markov models are limited in their limited ability to remember what occurred in previous model cycles. For example, the probability of what occurs after disease progression may be related to the time to progression. Although to some extent, health states can be defined ingeniously to address this complexity. Other modeling approaches may be required for more complex diseases. Markov models are useful when a decision problem involves the risk that is continuous over time, when the timing of events is important, and when important events may happen more than once. Representing such clinical settings with conventional decision trees is difficult and may require unrealistic simplifying assumptions. Markov models assume that a patient is always in one of a finite number of discrete health states, called Markov states. All events are represented as transitions from one state to another. A Markov model may be evaluated by matrix algebra, as a cohort simulation, or as a Monte Carlo simulation. A newer representation of Markov models, the Markov cycle tree, uses a tree representation of clinical events, and may be evaluated either as a cohort simulation or as a Monte Carlo simulation. The ability of the Markov model to represent repetitive events and the time dependence of both probabilities and utilities allows for a more accurate representation of clinical settings that involve these issues. There are 4 types of Markov models that are used situationally. Markov chain, used by systems that are autonomous and have fully observable states. Hidden Markov model, used by systems that are autonomous where the state is partially observable. Markov decision processes, used by controlled systems with a fully observable state. Partially observable Markov decision processes, used by controlled systems where the state is partially observable. Markov models can be expressed in equations or in graphical models. Graphic Markov models typically use circles, each containing states, and directional arrows to indicate possible transitional changes between them. The directional arrows are labeled with the rate or the variable one for the rate. Applications of Markov modeling include modeling languages, natural language processing or NLP, image processing, bioinformatics, speech recognition, and modeling computer hardware and software systems. Markov models are named after their creator, Andrei Markov, a Russian mathematician in the early 1800s to early 1900s. More about latent Dirichlet allocation. Latent Dirichlet allocation, or LDA, is often used for content-based topic modeling, which basically means learning categories from the unclassified text. In content-based topic modeling, a topic is a distribution over words. For example, assume that you have provided a corpus of customer reviews that includes many products. The text of reviews that have been submitted by many customers over time would contain many terms, some of which are used in multiple topics. A topic that is identified by the LDA process might represent reviews for an individual product A, or it might represent a group of product reviews. To LDA, the topic itself is just a probability distribution over time for a set of words. Terms are rarely exclusive to any one product, but can refer to other products or be general terms that apply to everything, like great, awful. Other terms might be noise words. However, it is important to understand that the LDA method does not purport to capture all words in the universe, or to understand how words are related, aside from probabilities of co-occurrence. It can only group words that were used in the target domain. After the term indexes have been computed, individual rows of text are compared using a distance-based similarity measure to determine whether the 2 pieces of text are like each other. For example, you might find that the product has multiple names that are strongly correlated, or you might find that strongly negative terms are usually associated with a particular product. You can use the similarity measure both to identify related terms and to create recommendations. Interpreting LDA results. To illustrate how the latent Dirichlet allocation module works, the following example applies LDA with default settings to the book review dataset provided in Azure Machine Learning Studio. The dataset contains a rating column as well as the full comment provided by the users. LDA model. In more detail, LDA represents documents as mixtures of topics that spit out words with certain probabilities. It assumes that documents are produced in the following fashion. When writing each document, you decide on the number of words n the document will have, say according to a Poisson distribution. Choose a topic mixture for the document, according to a Dirichlet distribution over a fixed set of k topics. For example, assuming that we have the 2 food and cute animal topics above, you might choose the document to consist of 1/3 food and 2/3 cute animals. Generate each word within the document by, first, picking a topic according to the multinomial distribution that you sampled above. For example, you might pick the food topic with 1/3 probability and the cute animal topic with 2/3 probability. Using the topic to generate the word itself according to the topic's multinomial distribution. For example, if we selected the food topic, we might generate the word broccoli with 30% probability, bananas with 15% probability, and so on. Assuming this generative model for a collection of documents, LDA then tries to backtrack from the documents to find a set of topics that are likely to have generated the collection. Learning. So, now suppose you have a set of documents. You've chosen some fixed number of k topics to discover and want to use LDA to learn the topic representation of each document and the words associated with each topic. How do you do this? One way, known as collapsed Gibbs sampling, is the following. Go through each document and randomly assign each word in the document to one of the k topics. Notice that this random assignment already gives you both topic representations of all the documents and word distributions of all the topics, albeit not very good ones. So, to improve on them, for each document D, go through each word W in D, and for each topic T, compute 2 things. First, P parentheses topic T pipe document D close parentheses equals the proportion of words in the document D that are currently assigned to topic T. And second, P parentheses word W pipe topic T close parentheses equals proportion of assignments to topic T over all documents that come from this word W. Reassign W to a new topic, where we choose topic T with the probability P parentheses topic T pipe document D times P parentheses word W pipe topic T close parentheses. According to our generative model, this is essentially the probability that topic T generated word W. So it makes sense that we resample the current word's topic with this probability. Also, I'm glossing over a couple of things here. In particular, the use of priors and pseudo-counts in these probabilities. In other words, in this step, we're assuming that all topic assignments except for the current word in question are correct, and then updating the assignment of the current word using our model of how documents are generated. After repeating the previous step a large number of times, you'll eventually reach a roughly steady state where your assignments are pretty good. So, use these assignments to estimate the topic mixtures of each document by counting the proportion of words assigned to each topic within that document, and the words associated to each topic by counting the proportion of words assigned to each topic overall. Conclusion. Text mining seeks pattern extraction from the analysis of large collections of documents in order to gain new knowledge. Its purpose is the discovery of interesting groups, trends, associations, and the visualization of new findings. Automatic categorization determines the subject matter from a document collection. This, unlike clustering, chooses the class to which a document belongs in a list of predefined classes. Each category is trained through a previously manual process of categorization. The classification starts with a set of training texts previously categorized, then generates a classification model based on the set of examples. This is able to allocate the correct class from a new text. A decision tree is a classification technique that represents the knowledge through if-else statement structure represented in the branches of a tree. Textual mining methodology provides a framework performed in 4 stages: data acquisition, pre-processing documents, information extraction, and evaluation of results. Witten, Frank, and Hall make mention of these steps in his work for the use of WEKA. Thanks again for buying my book. If you have a minute, please leave a review. I take reviews seriously and always look at them. This way, you are helping me provide you better content that you will love in the future. A review doesn't have to be long, just 1 or 2 sentences and a number of stars you find appropriate. Hopefully 5, of course. Also, if I think your review is useful, I will mark it as helpful. This will help you become more known as Amazon as a decent reviewer, and will ensure that more authors will contact you with free ebooks in the future. This is how we can help each other. You can look at these books too: Data Analytics, Data Mining, Data Science for Business. Disclaimer: this information is provided as is. The author, publishers, and/or marketers of this information disclaim any loss of liability, either directly or indirectly as a consequence of applying information presented herein, or in regard to use and application of said information. No guarantee is given, either expressed or implied, in regard to the merchantability, accuracy, or acceptability of the information. The pages within this ebook have been copyrighted. This has been Text Analysis: Python, Models, and Lexicons. Written by David Feldspar. Narrated by Jason R. Gray. Copyright 2018 by David Feldspar. Production copyright 2018 by David Feldspar.